now that we've got the basic boilerplate code done, what we're going to do is actually create a class for the player. So we're just going to go, we can do it right up here, right above the redraw game window function, and we're going to say class, player. We can just pass an object, and then we're going to create the init function. So def init, and what this is going to have is, for starters, it's going to have the image that we imported a little while ago. So we're going to say self.img is going to equal player rocket. I think that's what we called it up here. Yeah, and then so the player is going to have a width and the height, which the picture is 100 by 100, but like in case we change it later on, we're just going to say self.width is going to equal self.image .get underscore width. And then we'll copy that, paste it, and change the W to an H. And then here we'll say height. Perfect. And then we're going to give it an X and a Y value. So self.x is going to equal, we can start it off in the center. So we'll do like screen width divided by 2. And then self.y is going to equal screen height divided by 2. That should be good for now. Let's also create a draw function. So we're going to say def draw, and we're going to also pass in the window, so win, that we created right here. We're just going to do win.blitz and self.img, and then we're going to pass in an array of 4 values. The first one's going to be self.x, second one's self.y, third one is going to be self.width, and the fourth one is self.height. And yeah, so then right here above the while loop, we're just going to create the player. So we'll say player is going to equal a new player, and it takes in no parameters, so that is all we need. And then in order to get them displayed on the screen, we're just going to go up to the redraw game window, and we're going to say player.draw, and we'll pass in window. So now when we press run, and we check it out, we get our player right there. So that's going to be the ship that we're going to be controlling, and we'll be using the arrow keys. So up arrow key is going to make him move forward, right and left is just going to rotate him, and then the back arrow key is not going to do anything. So it's a little different than the usual controls of like just a basic character, because it's a ship, so we have to control it a little bit differently. And that's going to be a little bit of a challenge, but I'll explain how to fully integrate that. So now that we've got the player, I think before we get into before we like add all the asteroids and stuff, I want to get the controls down for the player, because it's kind of it's a little bit tedious. There's a lot of steps that go into it, because the up arrow key is not always just going to move the player higher up on the screen. Like basically, if we run this, and if I press up in its current position, if I press the up arrow key, he's going to move forward. But if I press the right arrow key, he's going to stay in the same position, but he's going to turn right. So if the front of it's facing this way and I press the up arrow key, it needs to go in this direction. So we constantly have to be keeping track of which direction the ship is facing, which is kind of where the problem comes in. Because if that wasn't the case, then I can just have X and Y velocities, and if I press the up arrow key, he would go up. If I press the down, go down, right and left. But that's not the case for this game. So in order to do that, we're going to need a couple of more parameters inside of the init function of the player. So what we're actually going to be doing is we're going to be keeping track of a couple different lists that are going to have values that we're going to reference later on. So before we create any of those, we need to keep track of the angle that the player is facing. So let's just say self.angle is going to equal 0 by default. So 0 is if it's facing straight up. And now what we're going to do is we're going to create a variable called self.rotated surf. That's just going to stand for surface. And what this is going to be is pygame.transform.rotate. And then we're going to pass in self.image. And then we're going to say self.angle. So what this does is this is what's actually going to be able to rotate it and kind of give us the new value of the image whenever it's rotated. What we're also going to need is a variable called self.rotedRect, which stands for rectangle, and that's going to be set equal to self.rotedSurface.getRect. So that is looking good. Now in order to, so right now, if you notice, whenever we run this, so we set the x and the y to the center, but you can see that it's offset, like, because basically whenever we set it to the center, it's getting the zero, it's getting the top left corner of the picture and setting that to the center. So right here where the mouse is the center of the screen, but we want the center of the ship to be in the center. So there's two ways we can do that. We can either just subtract half of the width and half of the height, which will move this center right there. Another way is simply by creating a variable called self. We're not really creating a variable, it's kind of, we're changing the value of something. So self.rotedRect, and then what we can do is we can just say dot center is going to equal self.x and self.y. So now the center of that sprite is going to be at self.x and y instead of the top left corner. And that'll help us out because whenever we rotate it, we want to rotate around the center of the picture as opposed to the top left corner, because that would just not look right. Next, what we're going to do is we are going to use sines and cosines. And sines and cosines are going to be how we can determine which direction the ship is facing after it's been rotated. So it's just like you learned in math class. So let's like start off with cosine. So self.cosine is going to equal math.cos, which stands for cosine. And what we're going to pass in here is a radian value of the degree that it's facing. So right now we're keeping track of angle and it's going to be in degrees. So in order to convert that to radians, we're just going to say math.radians and then self.angle plus 90. So the plus 90 is just going to fix the offset because, like I said, right now it's set to 0 and that's facing up, but if you remember anything from math class, like 0 degrees is actually, like if this is the graph, 0 degrees is off to the right side. So we're adding 90 to just kind of fix that offset, and then we just need to go up to the very top and import math so that we can actually use it right there for these functions. And then we're going to do the same thing for sine. So self.sine is going to equal math.sine. We're going to pass in math.radians of self.angle plus 90. So those two are looking good. And now the last variable that we're going to create inside of init is going to be called self.head, which is going to give us, it's basically going to give us the x and the y of the front of the ship. So whenever it's rotated, it'll always update and tell us where the front of it is. So that way we can know where the bullet needs to be shooting from and in what direction. So self.head is going to be set equal to self.x plus self.cosine times self.width divided by 2. And then we're going to do a comma, and then we're going to do the y, so self.y minus self.sine. And then we're going to do times self.height divided by 2. Alright, so that is all the variables that we are going to need in order to be able to shoot bullets out later on and kind of keep track of the direction of the ship. So I know it's a little bit, you know, it's pretty dense, but there's just a lot that goes into making sure the controls are really accurate for this. And so in order to get it to where it displays it properly and it rotates the picture whenever whenever it's been turned, what we're actually going to do is, instead of saying win.blit and just passing in the image and then the x, y, width, and height, we're just going to comment that out, go to a new line, and we're actually going to say win.blit. We're going to pass in two values. The first one is the self.rotated surface, and then the second one is going to be self.rotedRect. So this is going to be This is going to take into account if the sprite has been turned or not, so it'll keep track of which direction it's facing, and this is going to pass in the values as far as like the x, y, and the proper width and height, because when it rotates, those values constantly change. So when, like, if we just do it like this, that doesn't take into account the changes, but this will constantly make sure it's being updated. And then next, what we're going to need to do is we're going to create a few functions that are going to be called whenever the player presses the right or left arrow keys. So we're going to say self, and then like turn left. Whenever the user presses the left arrow, we're going to actually change the value of angle by 5. So we're going to add 5 to that angle. And then since the angle is going to be changed whenever the arrow is pressed, we have to update the rotated surface and the rotated rectangle. So we're going to say self.rotatedSurf is going to be equal to pygame.transform.rotate self.image and self.angle. Next, we're going to have to update the rotated rectangle as well. And we're going to set that equal to self.rotatedSurface.getRect. And then what we're going to do is reset the center. So we're going to say self.rotatedRect.center is going to equal self, in parentheses, self.x, comma self.y. And then same thing for cosine and sine, so self.cosine is going to equal math.cosine, math.radians of self.angle. We can copy that line, paste it down here, do self.sine, and then just change cosine to sine. Oh, and we also have to just add plus 90. So that is looking good. And then just the last thing is self.head needs to be reset. So we'll say in parentheses self.x plus self.cosine plus self.width divided by 2, and then self.y minus self.sine times self.height divided by 2. So that's everything we need in the turn left function. Then we can just copy this whole thing and then paste it down here and create a turn right function. And the only thing we have to change is self.angle and just make that say minus equals 5 instead. Everything else needs to be the same. And then so now we have the logic for the right and left arrow keys. The last arrow key that we need to take into consideration is the up arrow key, so we'll just create a function called move forward. That's if the user presses the up arrow. And what we need to do in that case is self.x is going to plus equal self.cosine times 6, and then self.y is going to minus equals self.sine times 6. And then here I put plus plus, it needs to be plus equals. So that is looking good, and then the rest of what we need in this method is just going to be all of these lines. We're going to copy them and paste them at the bottom. And yeah, that should be good. So now, in order to test and make sure that these functions are working correctly, we need to detect the key presses inside of our while loop at the very bottom. And the way that we're going to be doing that is by creating a list of all of the keys that get pressed. So we can just go right here under if not game over, and what we're going to do is we're going to create a list called keys, and it's going to be set equal to pygame.key.getPressed. So it's going to add a key into the list every time the user types something. And so if I press the right or left arrows, it'll detect that. And then so what we're going to do is if keys is pygame.k_left, Then we are going to call player.turnLeft. Then we're going to create another one, say if keys dot bracket pygame dot k underscore right. Then we are going to do player dot turn right. And lastly, if keys square bracket pygame dot k underscore up. Then we're going to call player dot move forward. And so that should be good. Let's run this and see what happens. So now if I press the up arrow, it crashes because we have forgotten an E here. We need an E in cosine. I think that's the only problem. So we did that up there as well and up here, so it's wrong in all of them, but just add an E and it should work. So now when I press the up arrow, it still crashes because we actually don't say cosine, we just say COS. Of course, okay. So make sure you update turn left, turn right, and move forward, and right here in self.cosine, we want to set it equal to math.cos in each of them, so it was the full word cosine, but it needs to just be COS. So now let's run this and check it. Press the up arrow, it moves. By turn, it moves. And so now it moves in the direction that is facing forward. So if I press right, it spins right. If I press left, it spins left. And then if I press forward, it moves forward. And so yeah, that it looks like it's fully functional. So those are the controls. I think that's going to end it for this part of the series. In the next video, what we're going to do is add the bullets, and then we'll start working on actually adding the asteroids and all of that type of stuff. I hope you guys enjoyed, and yeah, peace.